Welcome everybody. We got a beautiful question. Let me write the question down. In a parallelogram ABCD, a point P on the segment AB is taken such that AP over AB is equal to 61 over 2022, and a point Q on the segment AD is taken such that AQ over AD is equal to 61 over 2065. If PQ intersects AC at T, we are expected to find AC over AT. So this is the question. It looks very interesting. So foremost, what we will have to do is we will have to draw the parallelogram. So let me draw the parallelogram. I can draw this in freehand, but it doesn't look good drawing things in freehand. Okay. So we got A, B, C, D. This is the first point. In a parallelogram ABCD, a point P on the segment AB. So there is a point P on the segment AB is taken. So this point is P, such that AP divided by AB is equal to 61 divided by 2022. Now if this distance is taken to be as 61x, then naturally this distance is going to be from 2022, you subtract 61, that's going to be 1 and 6 and 9 and 1. So this distance is going to be 1961x. Now of course I'm taking it as x. It doesn't matter, because if this were to be 61x and this is going to be 2022x, naturally x and x can be cancelled, and still we will be getting 61 over 2022. So that wouldn't be a problem. So this is the point of intersection of the point P on the line AB. Now there is also another information given. We've been given, and a point Q on the segment AD is taken such that, so we got another point Q on AD. So let this be the point Q, and that is taken such that AQ is equal to 61. So this is 61, and AD, this entire length is 2065. So 2065, and I'm going to take this as Y, this is going to be Y. And what I wish to do is, I would like to extend this. Now this is actually a line segment. There is a line segment here. I am going to be extending this why am I extending this? Because I would have to obtain AC over AT. So there is an intersection that is taking place here. So to counter that intersection, I am extending the line segment. So let me draw this AC. So this is AC, and it is given that PQ, this line segment PQ, intersects AC at T. So this is going to be T. Now I have extended this because I would be applying a very important theorem to solve this question. That theorem is called as Menelaus' theorem. So what is this theorem exactly? This theorem states that if there is a transverse line intersecting a triangle, then we would be able to apply the formula provided by this Menelaus theorem. So I'm going to show you that particular formula, and this PQ is actually the transverse line because it is intersecting the triangle. If you were to take this triangle, it is intersecting the triangle at T as well as at P. So having mentioned that, let me just go on to extend this line and connect it, join it at this particular point R. So we got a full-fledged figure. Now why did I extend this? I extended this for the simple fact that if I were to consider this angle, then this angle would be same as this angle, and if I were to consider this angle, then by alternate segment theorem, this angle would also be same as this angle at B. So that is the reason I extend this particular line CB to meet PQ at R. So now if I were to consider triangle APQ and triangle BPR, clearly you can see that these two triangles are similar. How do I say that? Because you see that this angle and this angle are same, this angle and this angle are same. By angle similarity, we can conclude that triangle APQ is similar to triangle BPR. Now because of this fact that they are similar, I can actually obtain the value for BR. So I can get an equation from this. So what is the equation I can get? I can state the following equation. Because of the reason that the triangles are similar, I can state BR over AQ is equal to BP divided by AP. Now this can be rewritten as, because I'm interested in BR, that's the reason I'm obtaining this equation. BR divided by AQ. Now what is AQ? Now clearly you can see AQ is 61. So you can place that 61y is equal to BP. What is BP? BP is, this is the value we got, 961. So let me place that value, 961x divided by AP. What is the value that we got for AP? AP is 61x. So I can cancel the x and a x. I can cancel the 61 and a 61. I can push this y to the other side. So BR is 961y. So I'm going to write that value there, 961y. So that is nice. We did all this applying the similarities of triangle for the very fact that we wanted to obtain the value for BR. That is the objective. Now we see that there is a transverse line intersecting the triangle. I'm stating that inference which I've just mentioned. We observe that transverse line, when I'm talking about transverse line, we are talking about QP, is intersecting the triangle ABC, applying thus by Menelaus' theorem, we can actually state the following equation. So this is going to be, let me write that down here, AT divided by TC multiplied with CR divided by BR times BP divided by AP or PA is equal to 1. This is the formula we will be using. So I'm going to take this and put it over here. I have just placed this because you can have a better inference, or I would say better understanding of the formula. So let me write that down here. So this is going to be AT over TC times CR divided by BR times BP divided by PA is equal to 1. So we will just retain AT over CT. We got nothing to place there. Times CR. What is CR? Let's go back to the figure. CR. This is CR. Now you see this is a parallelogram. This AD is 2065. So this BC is going to be 2065. So therefore, what is CR? CR is going to be 2065 plus 1961, which is equal to 6, 12, 1, 10, 1, 4026. So place that 4026 divided by BR. BR value B is 1961. So 1961 multiplied with BP. BP value is 1961. 961. This is actually Y, right? This is actually Y. This is Y, and this is also Y. So we can place a Y there. So this is going to be 4026Y, and since we have a Y and a Y, both the Y's will be cancelled, right? So this Y and this Y will be cancelled, and similarly BP is 1961X. I'm just placing the X there, divided by PA. PA is 61X. 61X. So clearly we see that 1961, 1961, they get cancelled. Of course, I've already cancelled the Y's here. Now the X will also be cancelled. And what have we got? We have got 4026 divided by 61 is equal to 1. So moving 61 to the right and pushing 4026 down, this is going to be 80 divided by TC. Now 61 can divide 4026 66 times. So therefore we can write 80 over TC is equal to 1 over 66. Now let's go back to the figure. Now watch here. 80 over TC. 80 over TC is 1 over 66. So the ratio is 1 over 66, but we are expected to find AC over TC, or I should say AC over AT, right? Now AC, what is AC? AC is going to be, let me write the answer here, that's going to be 67, and AT is going to be 1. So the solution is going to be 67. Isn't it lovely? It's a beautiful question, and this is the answer to this question. So I hope you all enjoyed this question. Enjoy your night. Thank you.